of the exact value should you use when you calculate the percentage error?
Percent error can be there. It depends on how you interpret it. You can just go to rounding percent error off to the nearest integer, okay. Or I guess hundredth, however you want to look at that. If you have 15.2%, it is okay to round percent error off to 15%.
I know what I meant was, so you have your experimental and your theoretical value.
Right.
And how many significant figures should we, like, when we minus them together, how many significant
When you're doing the calculation, you should be using as much of the number as you can.
Okay.
It's only at the very end would you round off. All right, so but there was another question about finding percent error. So for part A or part B?
Part A, but it's the uncertainty of the percent of error.
Okay. And Austin, your question was about should we have an exact value for percent error for part B?
And I think I was reading something. I think I was reading something wrong. So I'll listen to what
Okay.
is going to be said before
All right.
I ask anything
All
further.
right, before I get into the math of it, just want to comment on for part B, you'll have your density with some uncertainty in it. You go to a table of densities, whether it's in a book or online, and you'll try to find a value that makes sense for that material. You know, you can pretty much be sure it's not made of mercury because it held its form. And so whatever material you think it is, assume that that book value is the correct value.
Okay.
So that's how you deal with that. So you have 3.17286 plus or minus 0.248. So let's just say that this happens to be your ratio of circumference to diameter. And you want to compare it to pi, because that's what the ratio should be. So percent error, experimental, minus the correct value. I'll put correct in quotation marks there. I do absolute value here. There are some instructors who care about the order. I don't. I take off for other things. But percent error implies that there is an error, which implies that there is an actual correct value. And so you'll compare this to the correct value. That'll get you some decimal, potentially, and then you multiply, then you get into percent form. Now, in this case, pi is the correct value, which I think is the answer to the first question. So when we subtract pi is actually an exact number. I mean, or close enough to it. You can take it out, there are websites out there, the first million digits of pi. So whatever you're willing to type in. So it's close enough to, there is no uncertainty in pi. And so the rules apply. So it's 3.1, so when you subtract 3.172896 minus pi, plus or minus the square root of this uncertainty, the 0.24 squared plus 0 squared, which is just the uncertainty of your calculation. So you'll end up with, the numerator is just your main number minus pi, and then it'll be that experimental, that'll be the uncertainty. The denominator, you're dividing by pi, so you're basically multiplying by a constant. And so you'll end up with 0.031 something, plus or minus 0.2489 something. And when you divide by pi, since it is a constant, technically pi plus or minus 0, then it's 0.301 yada 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 over pi, plus or minus 0.03. Let's try to be somewhat consistent with my made up numbers. Plus or minus 0.031 over pi times the square root of, well, my relative uncertainties. So 0.2, 4, 8, 9, whatever, over, I guess the difference, 0.031 squared plus 0 over pi squared. I'm going about it the long way, but it still works. So you have your main number here, and this is on your uncertainty. This obviously is 0 there. You just end up with 0.031 over pi times that uncertainty, which carries over to here, which carries over to here, 248 over 0.031. Those cancel out. So in essence, all you do is you have your main number divided by pi, plus or minus that uncertainty divided by pi. Did that address your question, Max?
Yeah, I got it.
Okay. Was it far more than you asked?
No.
Okay.
So I have one more question.
Yeah, Kyle.
When you're finding the volume and the area, do you need to include the uncertainty in that too? or-
Yes.
Okay.
I want uncertainties for, let's say, all the calculations. I mean, yeah, uncertainties throughout that.
Okay.
That's what makes it a fun lab. Just wait till the projectile motion lab. It'll be a dream come true. Other questions at the moment? Precious.
When they say which of the two variables that were measured contributes more to the uncertainty in the calculated ratio, does that mean what, like, of the two variables, which one has the higher uncertainty?
Not necessarily. It depends if you're adding, subtracting, or multiplying, dividing.
Okay.
But the uncertainty, if I'm multiplying or dividing, then my uncertainty, I basically have two fractions here. If I'm adding or subtracting, I'm dealing with absolute value, absolute uncertainties. And so I could get away with whichever one's bigger for adding and subtracting, but multiplying and dividing, you need to look at which has a greater contribution. Other questions? All right. Questions about things other than the lab? All right. I'll pick up sort of where we left off. Yep, it is recording. All right, so we got the big four properties of linear motion. We have position, displacement, velocity, and acceleration. So position is where an object is with respect to the origin. And I'll put in parentheses here, 0. If it's a number line, you generally don't call it 0 the origin, even though it is. Two-dimensional system, we have something, actually 2 dimensions and beyond, we generally have something called an origin. Displacement, where an object is with respect to the starting point. Which brings up the question of what exactly is the starting point? Is it from where the problem starts, or is it from the moment just before? And so that gets into two different types of displacement. If we're talking about overall displacement, which is the one that's implied. If I just say displacement, I'm talking about overall displacement. Overall displacement, the starting point is at the beginning of the problem. So the starting point at the beginning of problem. Now, generally, you have a freedom when you're solving a problem of making it. You can set up your own coordinate system. You can make the origin anywhere you want. It is usually convenient to make the origin and the starting point the same place. However, the exercise that we're about to go through, we're not going to do that. Velocity. Questions to hear before I just keep going?
Will we ever use instantaneous displacement?
Yeah, implied when we deal with velocity. So velocity, how fast and in what direction? And acceleration, I guess time rate, that's the word time. Let's see if I can actually spell it so it's readable. Time rate of change of velocity. Velocity could also be labeled as the time rate of change of position. Of change of position. Which is just displacement divided by time. This is all just vocabulary at this point. So what I want us to concentrate on now is sort of trying to be able to figure out when is it positive, negative, or zero. So the sign, S-I-G-N, in other words, plus, 0, or negative. For position, it depends upon what side of the origin you're on. So it is positive if on positive side of the origin. All right. So I'm about to walk back and forth in front of the board, a one-dimensional problem, or at least a simulation of it. And I'm going to make that the origin right there. Make that 0. And because in order, so if I'm at the origin, my position is 0. Something you need help reading?
No, I'm good now.
Okay. Now there's going to be some parallax here because I think Mario and Austin probably have the biggest slant to the angle here. If it looks like I'm about at the origin, then I'm at the origin. I don't want to fall into this max impression say I'm at the origin, you say I'm on the one side, and you say I'm on the other side. I'm not playing that kind of subtlety here. So we need to know which is the positive side, which is the negative side, so I'm going to make positive side over here. And the way this game works, in unison would be absolutely beautiful. I'm going to say my position is, and then your response is either positive, negative, or 0. Not all three of them, just pick one. Pick the correct one. So right now, my position is, that was nice. My position now, position now,
0.
my position now,
Negative.
my position now.
Negative.
All right, that's the way the game is played. Any questions about the game at the moment? The exercise, activity, whatever you want to call it. Displacement, it's positive if on positive side of starting point. I've already established positive is to your right. I'm going to make for this exercise, this is my starting point right here. So right now, so people are still writing, give people a chance to catch up. All right, so right now, my position,
Oh, your position's
yes, and this is why it gets more complicated because there's more vocab words I can throw out here. All right, so let's try that again. My position,
Positive.
my displacement,
Zero.
all right, there we go. My position,
Positive.
my displacement,
One.
I heard something other than negative.
Oh, I thought you said your displacement. I just had one because you moved one.
Just positive, negative, or zero. I'm on the negative side, it is negative. My position,
Negative.
displacement,
Negative.
all right. As I start to add more of these, the faster the response would really be helpful. It's only so slow I can go, although I can rewind. Velocity cares about which direction you're going in, so velocity is positive if moving in the positive direction. And obviously negative if it's moving in the negative direction. So right now, my position,
Positive.
kind of threw people off there. My displacement,
Positive.
my velocity,
Zero.
all right. Position,
Positive.
displacement,
Negative. Negative.
velocity,
Negative.
velocity,
Negative.
position.
Negative. Negative.
Yeah, that was, I'm glad you were answering for just before I stopped. All right. My velocity,
Positive.
position,
Negative.
Positive.
now it is, and, wow. I have to go a little bit faster too. All right, so rewind. All right, so my velocity
Positive.
is positive. And this is an instantaneous displacement because I was there, now I'm here, my instantaneous displacement was in the positive direction. My displacement,
Negative.
all right, not everyone was convinced on that one. Velocity,
Positive.
displacement,
Negative.
position,
Positive.
it is now, all right. Any questions up to here because we're about to get to the tricky one? We can look at acceleration a couple different ways. Way number one is if you're speeding up. Velocity and acceleration have the same sign. If slowing down, they're opposite signs. The other way of looking at it deals with forces, and I know we haven't really talked about forces in here, but just think of a push or a pull. If the net force is positive, acceleration is positive. If the net force is negative, acceleration is negative. So let's see how that plays out. So I'm starting right here. My velocity is 0. If I start moving in the negative direction, what will my velocity be? Because velocity cares about which way I'm going, so if I go in the negative direction, then it's negative. So negative velocity. So I went from 0 to some negative value. Did I speed up or slow down?
Speed up.
So my acceleration therefore was,
Negative.
Same
if I'm
sign.
speeding up, they're the same sign. And that's the biggest hurdle here, is so many people are convinced that positive acceleration means speeding up. No. Not the case just then. All right, so I start here, I start moving in the negative direction, so as soon as I start moving, I have negative acceleration. I'm starting here, and then I start moving in the positive direction. My acceleration at that moment that I started moving, I'm moving in the negative direction, and then I slow down.
Positive.
I'm moving in the positive direction, and I slow down.
Yeah.
Negative acceleration, in that case. Now let's think about it in terms of forces. I'm standing here at rest, and suddenly I start moving in that direction. Which way would I have to be pushed or pulled in order to do that? Yeah. If I'm here and I start moving in that direction, something has to be pushing me or pulling me in that direction. So therefore, the force is in the negative direction, acceleration is negative. If I'm moving in the negative direction and then I stop, which way does the force have to be applied to me in order to stop me? Acceleration is positive as I slow down. So this whole idea of the same sign comes from the fact that if you get pushed in the direction you're already moving, you're going to speed up. If you're pushed opposite the direction you're moving, you're going to slow down. Now the speeding up, slowing down works really nicely, but some people get really messed up at the transitions. So as I'm moving along, I stop and then I go back in the other direction. At that moment that I am stopped, so moving along, that I can't go from negative to positive velocities without going through zero, so I have to stop at some point. So as I move there and back, the exception, unless there's a rip in the space-time continuum, which is outside the scope of the course. So at that moment that I'm stopped, what was my acceleration? I heard a positive and a zero. Actually, I heard a 0 and a positive.
0.
Another vote for 0, another vote for 0.
0.
Any votes for negative? Moving in the negative direction. Stop for just a brief instant, then move back.
Are you talking about the moment when you stopped?
Yes.
0.
Wouldn't it be positive for you to stop?
All right, so we got 2 votes for positive. Jesse gave a nod of approval there. Not that you need external validation, but I think.
Velocity to have acceleration.
All right, so let's think about what acceleration is, because that's an important question. Acceleration, instantaneous acceleration, dv dt. Let's go sort of macroscopic, just why not? Average acceleration, change in velocity over change in time. If acceleration is 0, there's no change in velocity. So you're stopped at a stoplight. Your velocity is 0. If acceleration is 0 because you are stopped, that means your velocity won't change. And what's the implication? If you're at a stoplight, stopped, the light turns to green. If your velocity doesn't change because acceleration is 0, what's going to happen to you?
Constant.
A constant what?
Speed. 0.
Yeah, you'll never move. And I think most of us have experienced the fact that we have been at rest at some point and then not at rest. So it is possible to have acceleration and be stopped. So, you were right. It is positive. From a force point of view, if I am being at the turnaround, in order for me to stop and move back the other direction, something has to be pushing me. Basically, it's slowing me down and then pushing me back.
The
Mario?
first derivative of position gives you velocity, then the second derivative gives you acceleration.
Yes. All right, we got 4 things now. Ready? Here we go. Position. Displacement. Still considering this my starting point. Velocity.
0.
Acceleration. Because I'm at rest and staying that way. All right, so I just started moving. My acceleration. My acceleration now.
Negative.
I heard 2 different things there.
No, 0. If you're constant velocity, you're on 0.
Yeah, it was my attempt at constant velocity, yes. After I started moving, I'm pretending that I'm moving at a constant velocity here. There's no change, therefore acceleration is 0. My position,
Negative.
displacement,
Negative.
velocity, my acceleration at that moment.
Negative.
Negative.
They were negative. Because in order for me to, I'm moving in this direction, in order for me to stop, basically something has to stop me, so pushing in that direction, pushing against me, and then push me back. Pushing in that direction the entire time. Or I slowed down, so the signs were opposite. My velocity was positive, so my acceleration has to be negative. And then I started speeding up, velocity is positive, velocity is negative, acceleration is still negative. Here's another way of looking at the exact same thing. So I'm moving in the positive direction, I stop and I move back in the other direction. So I have time, velocity, but that's seconds, so that's meters per second. So 0, 1, 2, 3, 4. My velocity, we'll just say I was cruising along at 10 meters per second. You know, not world record pace, but close to it. And then I slow down at, let's say, then I'm going 5 meters per second. So from here to here, what's my change in velocity? Then 0, so what's again my change in velocity? Now I'm at -5, I'm going in the negative direction here. What's my change? -5. Change is always final minus initial. It's this minus that. My change again? Now this change in velocity, it's not acceleration, but change in velocity and acceleration are always the same sign. So my acceleration is constant here, because my change in velocity is constant for the same time increments, or close enough. But I'm slowing down, slow down, and then speed up. And acceleration is the same throughout the whole thing.
What is WRT? What's that?
Oh, here?
Yeah,
WRT, oh, with respect to.
with respect to. Thank
Yes.
you.
Shorthand notation from former math professors, just because we don't feel like writing. I think you're ready for the ball problem. Now, ordinarily, I'd have you sort of break into groups, but feel free to talk to people from a proper distance. Don't talk to someone on the other side of the room, unless you walk over there, please. So, the ball problem. Have any of you watched the video already? You did, and you watched the answer already?
Yeah.
Okay, so if you already know, if you remember it, you already know the answers, and you're working with somebody, just sort of let them struggle a little bit. Or if you're, army of one and not working with anybody, then just sort of sit there and smugly go, yeah, I know what the answer is. Ground. You throw a ball into the air. It goes up and then it comes back down. It's supposed to be a one-dimensional problem. I drew a little split there just so that you can see that there's motion there. In reality, it's just basically doing that. It goes up and then back along the same line. I'm going to define 4 times here. A, time just after ball leaves hand. So as soon as the ball leaves the hand, that's when time A is. Time B. B is the time when ball is at the peak. C, the time when ball is at same position as it was at time A, but on the way down. So at time A and time C, the ball's in the exact same location, just at time A it's going up, time B, C it's going down. And then D, time just before ball touches ground. All right, questions up to here about what the problem that's being laid out so far? I need to do a couple more things before I set you loose. Awesome.
So where are we defining the axis for positive position?
That's the next thing I need to do. I'm going to let the ground be my origin. Ground is 0. And just so that we're all on the same page, ordinarily in a problem like this, if this were like a test, and I was asking actually specific information, you could determine what's positive and negative direction, but just so that we all are working towards the same answer, let's make up positive. And I think that answers your question, Austin? Okay. Any questions about the problem before I state exactly what I want you to do? Right. Recognize that at time A, ball is here, time B, time C, and then time D. But the ball also exists between those times. So what I want you to do is tell me what is the position, displacement, velocity, and acceleration